Welcome to the Junos OS Design and Architecture module. By the end of this module, you should be able to describe the Junos OS and its basic design architecture. Junos OS is a trusted and secure network operating system. Junos OS powers the high-performance network devices offered by Juniper networks, such as routers, switches, and firewalls. Junos OS, depending on the device, runs on a modified and hardened version of either FreeBSD or Linux. Having Junos OS running on all network devices gives administrators the ability to have one operating system network-wide, and thereby dramatically reducing the complexity of network management. The Junos OS is divided into multiple software processes. Each process handles a portion of the device's functionality. Each process runs in its own protected memory space, ensuring that one process cannot directly interfere with another. When a single process fails, the entire system does not necessarily fail. This modularity also ensures that new features can be added with less likelihood of breaking current functionality. The Junos High Availability, or HA features, makes the insertion of device line cards and network OS upgrades a non-service impact event. Junos OS enables meaningful device configurations by providing an intuitive configuration hierarchy and including the ability to annotate the configuration. Configuration management is also made easier with the ability to perform syntax checking before committing the configuration, and when needed, enabling configuration rollbacks after the configuration has been committed. Junos OS supports fine-grained network traffic controls, while separate control and data planes increase reliability and security. Over time, Junos OS has evolved from a monolithic operating system to a disaggregated network operating system, where the Junos OS has become independent of the hardware, and the operating system itself has been separated into its individual parts. This disaggregation enables a more flexible licensing consumption model for network applications and enables a DevOps approach that simplifies complex network operations and improves service agility. Junos OS has always included automation and now includes a wide range of automation capabilities using representational state transfer, or REST, Network Configuration Protocol, or NetConf, SONiC, and gRPC APIs. Note that for in-depth coverage of Junos OS, refer to the Juniper documentation website. You can access the website from the reference links document. As mentioned earlier, with Junos OS, it is possible for all devices network-wide to run one operating system, Junos OS. All platforms running Junos OS use the same source code base within their platform-specific images. This design ensures that core features work in a consistent manner across all platforms running Junos OS. Because many features and services are configured and managed the same way, the setup tasks and ongoing maintenance and operation within your network are simplified. Juniper Networks releases a new version of Junos OS typically each quarter of the year. Junos OS releases are numbered using the form M.NZB.S, where M.N are the main and minor release numbers that give the Junos OS version. For example, 21.1, which indicates the first quarter of the year 2021. The Z denotes the release type, B is the build number of the product, and S is the spin number of the product. The most common type of release is the R release type. The R1 release is the first revenue ship, or FRS release. The R2, R3, and following releases are maintenance releases. New R releases such as R2 and R3 include bug fixes only. That is to say, version 20.3R2 does not contain any features not included in 20.3R1. New features are not introduced until version 20.4R1. When you upgrade a Juniper device running the Junos OS, the Junos OS software upgrade packages also follow the naming convention just described. Although individual architecture modules of Junos OS communicate through well-defined interfaces, Each module runs in its own protected memory space, preventing one module from disrupting another. It also enables the independent restart of each module whenever required. This is in contrast to monolithic operating systems, in which a malfunction in one module can ripple to other modules, possibly causing a full system crash or restart. This modular Junos OS architecture provides a high level of performance, availability, security, and device scalability not found in other operating systems. The example shows some of the common software processes running inside Junos OS, which can be verified with the Show System Processes extensive CLI command. For a brief overview of the main Junos OS processes, refer to the document provided in the Resources section. Another aspect of Junos modularity is the separation of the control plane and the forwarding or data plane. The processes that control the routing and switching protocols are cleanly separated from the processes that forward the frames, packets, or both through a device running Junos OS. This design enables you to tune each process for maximum performance and reliability. The separation of the control and forwarding planes is one of the key reasons why Junos OS can support many different platforms from a common codebase. The example illustrates a basic view of the Junos OS architecture and highlights the control and forwarding planes. The control plane, shown above the dashed line, runs on the routing engine. The routing engine is the brain of the platform. It is responsible for performing protocol updates and system management. The routing engine runs various protocol and management software processes that reside inside a protected memory environment. The routing engine is based on an x86 or PowerPC architecture, depending on the specific platform running the Junos OS. The routing engine maintains the routing tables, also known as routing information base or RIB, bridging table, and primary forwarding table, also known as forwarding information base or FIB, and connects to the packet forwarding engine through an internal link. Although all Junos OS devices share this common design goal, the actual components that make up the control and forwarding planes vary between the different Junos OS devices. For additional details about a specific Junos OS device, refer to the Juniper Networks Tech Library website. You can access the website from the reference links document. The PFE, shown below the dashed line, usually runs on separate hardware and is responsible for forwarding transit traffic through the device. In many platforms running Junos OS, the PFE uses ASICs for increased performance. Because this architecture separates control operations, such as protocol updates and system management, from forwarding operations, platforms running Junos OS can deliver superior performance and highly reliable deterministic operation. The PFE receives the forwarding table from the routing engine by means of an internal link. Forwarding table updates are a high priority for the Junos OS kernel and are performed incrementally. Because the routing engine provides the intelligent side of the equation, the PFE can simply perform as it is instructed. That is, it forwards frames, packets, or both with a high degree of stability and deterministic performance. This architectural design also makes possible the incorporation of high availability features, such as graceful routing engine switchover, or GRESS, non-stop active routing, or NSR, and unified in-service software upgrades, or ISSUs. Now that you have had a basic introduction to the routing engine and the packet forwarding engine, take a closer look at the routing engine. In addition to the processes that control the interfaces on a device, the routing engine also handles protocol processes, chassis components, user access, and other system management tasks. These software processes run on top of the Junos kernel, which interacts with the PFE. The routing engine performs three main tasks. The Junos OS software directs all protocol traffic, such as OSPF and BGP routing information, from the network to the routing engine for the required processing. The routing engine provides the CLI and the JWeb GUI. These user interfaces run on top of the Junos kernel and provide user access and control of the device. The routing engine controls the PFE by providing accurate, up-to-date Layer 2 and Layer 3 forwarding tables, and by downloading microcode and managing software processes that reside in the PFE's microcode. The routing engine receives hardware and environmental status messages from the PFE and acts upon them as appropriate. The PFE is the central processing component of the forwarding plane. The PFE uses ASICs that are physically located on the system board or line cards. In all recent Juniper devices, a line card hosts a handful of PFEs. Utilizing multiple PFEs in a line card is a way of scaling the device's capacity. The PFE performs two main tasks. The PFE systematically forwards traffic based on its local copy of the forwarding table. The PFE's forwarding table is a synchronized copy of the information created on and provided by the routing engine. Storing and using a local copy of the forwarding table enables the PFE to forward traffic more efficiently and eliminates the need to consult the routing engine each time a packet needs to be processed. Using this local copy of the forwarding table also enables platforms running the Junos OS to continue forwarding traffic during control plane instabilities. The PFE also maintains Layer 2 bridging information. In addition to forwarding traffic, the PFE also implements a number of advanced services. Some examples of advanced services implemented through the PFE include policers that provide rate limiting, stateless firewall filters, and class of service or COS. Other services are available through special interface cards that you can add to the PFE complex. Welcome to the Junos OS Traffic Processing and Software Evolution module. By the end of this module, you should be able to describe traffic processing and evolution of Junos OS. Transit traffic consists of all traffic that enters an ingress network port, is compared against the forwarding table entries, and is finally forwarded out an egress network port toward its destination. A forwarding table, also known as Forwarding Information Base or FIB entry for a destination, must exist for a device running Junos OS to successfully forward transit traffic to that destination. Transit traffic passes through the forwarding plane only and is never sent to or processed by the control plane. By processing transit traffic only through the forwarding plane, platforms running Junos OS can achieve predictably high performance rates. Transit traffic can be both unicast and multicast traffic. Unicast transit traffic enters one ingress port and is transmitted out exactly one egress port toward its destination. Although multicast transit traffic also enters the transit device through a single ingress port, it can be replicated and sent out multiple egress ports depending on the number of multicast receivers and the network environment. Unlike transit traffic, exception traffic does not pass through the local device, but rather requires some form of special handling. Examples of exception traffic include packets addressed to the chassis, such as routing protocol updates, telnet and SSH sessions, pings, traceroutes, and replies to traffic sourced from the routing engine. IP packets with the IP options field set. The options field in the packet's IP header is rarely seen, but the packet forwarding engine, or PFE, was purposely designed to not handle IP options. Packets with IP options must be sent to the routing engine for processing. Internet Control Message Protocol, or ICMP messages. ICMP messages are sent to the packet's source to report various error conditions and to respond to ping requests. One example of an ICMP error is a destination unreachable error, which is sent when no entry is present in the forwarding table for the packet's destination address. A second example of an ICMP error is a time to live or TTL expired message, which is sent when a packet's TTL is decremented to 0. In most cases, the PFE process handles the generation of ICMP messages. The Junos OS sends all exception traffic destined for the routing engine over the internal link that connects the control and forwarding planes. The Junos OS rate limits exception traffic traversing the internal link to protect the routing engine from denial of service or DOS attacks. During times of congestion, Junos OS gives preference to the local and control traffic destined for the routing engine. The Junos OS has evolved over time. It has existed in 4 different architectural forms. Junos OS started out as a single entity. In traditional Junos OS, the control plane, the forwarding engine, and all of the hardware drivers are modularized components of a single image. This software image is tightly bound to its underlying hardware. Virtualized Junos OS takes advantage of virtualization technologies to run Junos OS in a virtual machine, or VM, on top of the kernel-based virtual machine, or KVM, or VMware hypervisor. Note that all the components of Junos OS are still fused into a single image. The virtual SRX or VSRX and virtual MX or VMX products are examples of virtualized Junos OS. Further development of Junos OS took the advantage of virtualization further and separated the packet forwarding engine software and platform-specific components from the core operating system. The control plane and the daemons attached to the control plane remained with the FreeBSD kernel, but the operating system was opened up to external APIs, and the packet forwarding engine and platform-specific software was no longer directly embedded in the operating system. Disaggregated Junos OS separated the platform drivers and the forwarding engine, packet forwarding engine software, and is running them in their own virtual environments directly on top of Linux. The NFX series devices use disaggregated Junos OS. This disaggregation brings a number of advantages. Removing the platform drivers and forwarding engine from the control plane image and running them in another thread improves the control plane performance significantly. The Junos OS virtual machine is now hardware independent and focused only on the control plane, speeding up the innovation process. Linux is a multi-threading OS. CPUs are multi-core. The disaggregated Junos OS architecture permits Junos OS to pin software to different processor cores, and third-party binaries or other applications can make use of additional CPU cores. Unified in-service software upgrade, or ISSU, is facilitated. Different versions of Junos OS can run in separate virtual machines. The virtualization infrastructure permits users to install third-party applications and tools on supported switching, routing, and security platforms. The last stage of evolution of Junos OS follows the trend of cloud computing, where systems leverage pools of hardware to perform tasks. This is the core concept of Junos OS Evolved. With Junos OS Evolved, the legacy FreeBSD kernel is removed. Because the core functions of legacy Junos OS were attached to the kernel directly as software daemons, the daemon processes have been redesigned to run independently of the kernel. In other words, they have been rebuilt as applications, independent from the underlying kernel, but are based on the same functionality and code concepts of the original daemons. In legacy Junos OS, information related to a daemon is managed, modified, and stored by the respective daemon. When that daemon experiences a fault or a restart, the information it manages and stores is lost, unless a system is implemented to run a backup of the daemon, which tries to synchronize its information with the primary daemon. This type of hot standby is inefficient and difficult to manage. With Junos OS Evolved, the applications that perform functions no longer store the information they process internally to the application. The application is a consumer or publisher of information. Information is sent to the application. It processes the information according to its design and publishes the results to a centralized, distributed database, much like a data center environment. If an application experiences a fault or is restarted, the new instance of the application retrieves the state information that the previous instance of the application had stored in the database, and the information is not lost. Because the functions of Junos OS Evolved are application-based and run on a Linux hypervisor, third-party applications that are developed to run on the hypervisor can be implemented as well. And because the information related to all processes on the device are stored in a distributed state infrastructure or database, third-party applications can be developed as consumers of that state information, which retrieve information from the data store for administrators, management platforms, and so forth. They can also be developed and implemented as publishers of information, which can publish information into the data store as long as it is formatted properly and utilizes the built-in APIs. Junos OS devices do not support the new Linux kernel or the distributed processing capabilities required to run Junos OS Evolved. Currently, Junos OS Evolved is planned for the cloud domain-oriented platforms, such as QFX and PTX series devices. Eventually, all new Juniper hardware can support Junos OS Evolved. Welcome to the Juniper Hardware Products Overview module. By the end of this module, you should be able to provide a brief overview of Juniper hardware products. Platforms running the Junos OS come in many shapes and sizes and are targeted for a number of deployment scenarios. The platforms running the Junos OS span switching, routing, and security, and are well suited for a variety of network environments. As the heart of all these platforms, Junos OS provides a consistent end-to-end IP infrastructure in both small enterprise environments as well as the largest service provider networks alike. Some of the routing devices that run the Junos OS are as follows. The ACX series products deliver simplified end-to-end provisioning and support Layer 2 and Layer 3 functionality with IP or MPLS traffic engineering. The fixed 1U ACX series models are environmentally hardened and support passive cooling, fanless design for outdoor deployments. For additional in-depth details on the ACX series, refer to the Juniper Product Services website. You can access the website from the reference links document. The MX series Ethernet services routers provide up to 80 terabits per second, or TBPS, of aggregate half-duplex throughput. The MX series family is targeted for dense dedicated access aggregation and provider edge services in medium and large points of presence, or POPs. Large enterprise environments and service providers can leverage MX series Ethernet services routers for a variety of network functions, including Ethernet transport and aggregation, and can use them to offer new Ethernet-based services. For additional in-depth details on the MX series Ethernet, refer to the Juniper Product Services website. You can access the website from the reference links document. The PTX series packet transport switches provide up to 460.8 terabits per second of throughput in a single chassis. The PTX series family is ideal for the service provider, SuperCore, and can readily adapt to today's rapidly changing traffic patterns for video, mobility, and cloud-based services. For additional in-depth details on the PTX series, refer to the Juniper Product Services website. You can access the website from the reference links document. Other devices, such as SRX series, also provide routing. For more information about all of Juniper's routing devices, refer to the Juniper Product Services website. You can access the website from the reference links document. Some of the switching devices that run the Junos OS are as follows. The EX series Ethernet switches provide up to 13.2 terabits per second of throughput. The EX series switches are designed for access, aggregation, and core deployments and are well suited for low-density to high-density enterprise and data center environments. For additional in-depth details on the EX series Ethernet switches, refer to the Juniper Products Services website. You can access the website from the reference links document. The QFX series switches provide a high-performance, ultra-low latency, feature-rich Layer 2 or Layer 3 device with a wire speed of 10, 25, 40, 100, 400 gigabit Ethernet or GBE throughput, and standards-based fiber channel I/O convergence. For use in data center environments, it provides a ready solution for an Ethernet VPN, Virtual Extensible LAN, or EVPN, VXLAN system. For additional in-depth details on the QFX series Ethernet switches, refer to the Juniper Products Services website. You can access the website from the reference links document. For more information about all of Juniper's switching devices, refer to the Juniper Products Services website. You can access the website from the reference links document. One of the security devices that run the Junos OS is the SRX series services gateways. The SRX series services gateways provide up to 2 terabits per second of full duplex throughput. The SRX series family is designed to meet the network and security requirements for consolidated data centers, managed services deployments, and aggregation of security services in both enterprise and service provider environments. For additional in-depth details on the SRX series, refer to the Juniper Products Services website. You can access the website from the reference links document. Other Juniper security products include next-generation firewall services, which include advanced application visibility and control, user and role-based policies, nested application support, and SSL inspection. SecIntel, which is the Juniper's curated security threat intelligence feed. Advanced Threat Prevention, or ATP appliance. The JATP series on-premises appliance collects and processes security events identified by the SRX and third-party security products, finds and blocks both known and unknown cyber threats. Cloud-based ATP, or ATP Cloud, which is a cloud service add-on to the SRX series firewalls. Using SecIntel across the network, ATP stops threats in their tracks by enforcing protection mechanisms at all points of connection on the network. Juniper Secure Analytics. JSA series appliances, available in both physical and virtual formats, provide security information and event management, or SIEM system that consolidates large volumes of event data from thousands of devices, endpoints, and applications into actionable intelligence. Some other Juniper security products include Juniper Secure Connect, which is a highly flexible SSL VPN application that gives remote workers secure access to corporate and cloud resources, providing reliable connectivity and consistent security to any device, anywhere. Juniper Secure Connect is available for desktop and mobile devices, including Windows, Mac OS, Android, and iOS. When combined with the SRX series services gateways, it helps organizations quickly achieve optimal performance and connectivity from client to cloud, reducing risk by extending visibility and enforcement to users and devices wherever they are. Juniper Identity Management Service, or JIMS, is a Windows-based application that links IP addresses to specific user identities, providing visibility into and control over network activity on a per-user basis. JIMS integrates directly with Active Directory servers to verify user-to-IP address relationships and determine specific role and group assignments. This enables SRX series services gateways to manage security policy decisions that directly associate application activity to user roles. Based on this information, the SRX series firewall either permits or denies users access to applications and data based on detailed security policies. For more information about all of Juniper's security products, refer to the Juniper Products Services website. You can access the website from the reference links document. Juniper Customer Premises Equipment, or CPE devices, are a group of products designed to integrate Junos OS into cloud-based solutions. For a full overview of SDN products, refer to the Juniper Products Services website. You can access the website from the reference links document. The NFX series network services platforms are Junos OS CPE devices designed to provide faster custom service delivery on demand, including software-defined WAN, or SD-WAN. These secure on-premises devices can run and chain multiple virtualized network functions simultaneously in an open environment. The NFX series also supports embedded vSRX security functionality. For additional in-depth details on the NFX series devices, refer to the Juniper Products Services website. You can access the website from the reference links document. Juniper is leading the convergence of Wi-Fi, Bluetooth Low Energy, or Bluetooth LE, and Internet of Things, or IoT, with the enterprise-grade access points. The AP series access points work in conjunction with the Juniper Mist Cloud architecture and Mist AI to collect and analyze metadata in near real time from all wireless clients. These access points are all built on a real-time microservices platform and are managed by the Juniper Mist Cloud. The BT11 is an enterprise-grade access point exclusively for Bluetooth Low Energy. It leverages Mist's patented VBLE antenna array, cloud subscription services, and the Mist AI engine to enable high-value location-based services, such as wayfinding, asset location, conference room usage analytics, and various contact tracing or social distancing use cases. The Mist Edge uses the Mist Cloud and is distributed software architecture for scalable and resilient operations, management, troubleshooting, and analytics, all without the need for legacy wireless controllers. For large campus networks, Edge provides seamless roaming through on-premises tunnel termination of traffic to and from access points. Mist Edge extends VLANs to distributed branches and telecommuters to replace remote VPN technology. Split tunneling enables guest access in corporate traffic, and Edge provides dynamic traffic segmentation for IoT devices. For additional in-depth details on the wireless access point devices, refer to the Juniper Products Services website. You can access the website from the reference links document. Wi-Fi Assurance Cloud Service, Juniper's machine learning driven by Mist AI, replaces manual troubleshooting tasks with automated wireless operations. This subscription service makes Wi-Fi predictable, reliable, and measurable with unique visibility into user service levels. The Wired Assurance Cloud Service with Mist AI enables simpler operations, streamlined troubleshooting, and better visibility into the experiences for your connected devices. It leverages rich Junos OS telemetry to deliver AI-powered automation and service levels, and also onboards, provisions, manages, and troubleshoots Juniper EX series switches. WAN Assurance Cloud Service enables simpler operations, better visibility into end-user experiences, and shorter mean time to prepare for your connected wired and wireless devices, including IoT endpoints based on application telemetry data across the WAN. Now you can use the Juniper Mist Cloud solution with Mist AI to deliver better user experiences for the SD-WAN with Session Smart Routers, SRX series gateways, or both. The Marvis Virtual Network Assistant, or VNA Cloud Service, is the first AI-driven network assistant for enterprise networks. It simplifies everyday troubleshooting with self-driving actions and network performance analysis with real-time answers, transforming how IT teams interact and engage with networks to streamline operations and boost user experiences. For additional in-depth details on the Juniper Mist Cloud services, refer to the Juniper Products Services website. You can access the website from the reference links document. Welcome to the Juniper Software Products module. By the end of this module, you should be able to explain Juniper software products. The Junos OS can also run as a virtual machine, or VM, using either VMware or KVM as the hypervisor. The Virtual SRX Platform, or VSRX, is a virtualized version of the Juniper Network's SRX series security gateway platform. It retains the same software components and functions as its hardware counterpart, including the separate control and forwarding planes. It protects virtual machine traffic and the virtualized network at the tenant virtual network edge. For additional in-depth details on the VSRX, refer to the Juniper Products Services website. You can access the website from the reference links document. The Virtual MX or VMX router is a full-featured carrier-grade router that offers the same quality and features of the physical MX series platform. The VMX provides complete control, forwarding, and management planes. The software emulation of the MX hardware is executed down to the level of compiling the microcode of forwarding ASICs into x86 instructions. This ensures that VMX packet handling and forwarding is identical to that of a physical MX router. For additional in-depth details on the VMX series, refer to the Juniper Products Services website. You can access the website from the reference links document. The VQFX 10000 makes it easy for you to try out the QFX 10000 high-performance data center switch without the wait for physical delivery. Although the virtual version has limited performance, it emulates the same features of the physical switch for the control plane, or both its control and data planes. Use the VQFX 10000 to create an instant virtual lab for a demo, proof of concept, training, script development, configuration validation, network change simulation, and more. For additional details, refer to the Juniper VQFX 10000 website. You can access the website from the reference links document. There is also a containerized, simplified version of the SRX called the CSRX. The advantage of a containerized implementation is that deployment and spin-up of containers can be much faster than deployment and spin-up of virtual machines. This is useful in large data center environments with fluid virtual topologies. The CSRX container firewall protects your containerized environments with advanced security services, including content security, intrusion prevention system or IPS, app secure, and unified threat management or UTM. For more information on the CSRX platform, refer to the Juniper Products Services website. You can access the website from the reference links document. Junos OS Containerized Routing Protocol Process, daemon, or CRPD, delivers Juniper routing applications in a container that can run on a white box with software for open networking in the cloud, or SONiC, or a server running the Linux OS, providing a single routing stack across the infrastructure independent of the underlying hardware. Junos OS CRPD supports use cases such as egress peer engineering to select the best path for service routes, route reflector for scale-out fabric, routing redundancy, and application high availability with routing on the host. For more information on the CRPD platform, refer to the Juniper Products website. You can access the website from the reference links document. Contrail is an SDN-enabled management and control software for simplified service delivery. Contrail offers intelligent networking, increased security, and advanced analytics, all with automation from multi-cloud and telco cloud. Contrail Cloud is an advanced telco cloud platform engineered to help service providers design, implement, and operate more agile and automated network infrastructures. Contrail Networking provides end-to-end networking policy and control for any cloud, any workload, and any deployment from a single user interface. Contrail Service Orchestration designs, secures, automates, and runs the entire service lifecycle across SRX series next-generation firewalls and NFX series network services platforms. For more information on the Juniper SDN products, refer to the Juniper Product Services website. You can access the website from the reference links document. Junos Space Network Management Platform is a comprehensive network management solution that simplifies and automates management of Juniper's routing, switching, and security devices. Junos Space Management applications are plug-and-play, domain-specific applications that help you to provision new services and optimize workflow tasks across thousands of Juniper devices. They include Security Director, Network Director, and Cross-Provisioning Platform. Juniper Sky Enterprises is a cloud-based management portal designed to abstract, simplify, and hide network complexity from branch and campus customers. It eases network administration and costs by eliminating the software maintenance cycles and dedicated network management infrastructure. It also greatly simplifies network operations by automating time-consuming tasks. For more information on the Juniper Network Management products, refer to the Juniper Products Services website. You can access the website from the reference links document. Juniper Paragon Automation is a modular portfolio of cloud-native software applications that deliver closed-loop automation in the most demanding 5G and multi-cloud environments. These solutions translate business intent into real-world performance across the lifecycle of network and services. They eliminate manual tasks and processes, empowering operations teams to work more quickly, efficiently, and accurately. They protect customers and businesses by measuring real service quality on the data plane, assuring that users have a consistent, high-quality experience throughout the life of their service. The Juniper Paragon Automation Suite includes the following. Paragon Planner, formerly known as North Star Planner, is a network planning and simulation tool that provides in-depth network views, health audits, and scenario planning without impacting your live network. Paragon Pathfinder, formerly known as North Star, is a powerful and flexible traffic engineering solution that simplifies and automates provisioning, management, and monitoring of segment routing and IP or MPLS flows across large networks. Paragon Insights, formerly known as HealthBot, is a highly automated cloud-native data collection and analytics solution that uses ML algorithms to provide coherent and actionable operational intelligence across network deployments. Paragon Active Assurance, formerly known as Netrounds, is an active network test solution that provides Layer 2 to Layer 7 measurement capabilities for service verification across physical and multi-cloud networks. The other applications in the Juniper Paragon Automation Suite include Apstra Fabric Conductor, formerly known as AOS, is an Apstra intent-based system, or AIS software, for data center networks to easily automate, manage, and monitor your data center fabric, simplifying Day 0 through Day 2 operations. AIS automates all aspects of the network design, build, deploy, and operation phases. Session Smart Router, formerly known as 128 Technologies, is a user-centric SD-WAN that delivers game-changing insights and automation from client to cloud. Anuta Atom, a Juniper Networks partner product, is a cloud-native modular service orchestration platform that provides closed-loop automation for provisioning, managing, monitoring, and assuring networks and services. For more information on the Juniper Network Automation portfolio, refer to the Juniper Product Services website. You can access the website from the reference links document.